from your Jamboard, you're going to see that you have the Boolean expression. Why I started with this exercise? Because just now I have another class, but when I apply this bar 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 bar, they cannot solve it. Wait, did I correctly? A B C bar bar bar. Okay, this one. A bar bar bar. Okay, correct. So please make sure you try to solve this question and discuss with your friend. Please, maybe you have a group leader, right? Last time also you have group leader. So please make sure the group leader check that all of your team members are participate with answering the question, and you discuss it all together. Okay? Please try to do it starting from now. This one is yes. What is your question? What was the group again? Huh? Last time you don't have group. In
Miss, I think last time you didn't have group numbers. I think we just submitted with our names, maybe, because I also forgot our group number.
wait, let me share you my screen. This one is not from your class, Barabi. Oh, Ikmal, Amirul. Oh, this one is not from your class. This is section 03. Okay. What you need to do. Okay, last time I did ask different section. They need to contact their friend, which is your group member. So from here, how much? You have about 30, 35. How many group? Four. If four, going to have. Okay, in one group, you need to have six, 5 to 6 members. So the maximum will be 6 in one group. So last time, another section, I not going to give who is your team member, but you need to find yourself. You need to start WhatsApp, or maybe you chat your friend here, whether they want to join you as a team, or maybe you want to be a leader, or maybe you just point out someone else. So you need to create your own group. Siapa who those who did not have group, so you'll be punished, because this is how you need to learn to be like selling yourself to find a job. So you are the one need to find someone else to join their groups. Okay, so start now, find your group member using your WhatsApp, because we have group, right? But don't create any WhatsApp group. We need to join the class. Huh? We need to join the class. What, Danny? I don't understand. So don't paste any information in your group section 06. So you need to PM them personally. Okay? Did you understand? So PM anyone. Doctor, we need to send the member list to you, right? Yes. For leader, maybe you just write down your name at the Jamboard. So list all the members in your Jamboard. Group one, group
Sorry,
two.
sorry, doctor.
Yes.
Can you share the attendance slide again, please?
Okay, wait. So like this one, wait, I show you. Let's say there is one groups. So you put their names, what is their names, and then your team members and so on. So you just started using your Jamboard. Okay, this is the QR code. So please try to find your group member. So for those who did not get a group member, so you're going to be punished. You need to have only 6 group altogether. Maximum will be 6 in a one group. Salah. I cannot see any one of you. Okay, one group already. Got here. I can see 6 times 6 is 39, 36. Okay.
Uh, Doctor, excuse me,
Yes.
doctor. I cannot edit the Jamboard.
Huh? I thought I already. Anyone with the internet can edit. Anyone with the link can edit. Yes.
My one it shows only view only. I'm not able to type in anything or add anything. I don't
Anyone
know.
have?
Same doctor.
Huh?
I can edit.
You can edit.
Can.
Can't.
I have the same issue, man.
I have the same issue, doctor.
But how? Because let me see over here. Anyone with the link can edit, copy, and then copy link. again, maybe. It is similar link. Can you edit now?
Yes, after I refresh.
Oh, after refresh.
Can doctor.
Okay.
Thank you, doctor.
Okay. I give you until 2:30 only. Is it okay? I think because it is not too hard the question. Maybe the problem is you need to find your group member. What I can see at the page one, don't pick the similar page with others, okay?
Doctor, I think we are out of pages.
I think 6 over stick times 6 is 36. But it's okay. Maybe if you want me to add another pages, let me add one.
Yeah, yes, please. We want.
Page number 7.
Yes.
How do you think when you look into the question? Is it easy or is it hard? Or maybe you feel confused?
So, doctor, should we only simplify or do input
No,
and output?
it's better for you to write step by step.
Yeah, simplify it or we do input and output.
Okay, maybe you need to apply only like one or two rules from Boolean rules, but no need for you to fully simplify. It is just like until you reach one input having bar. Okay,
Oh,
so
okay, got it.
mm, only the theorem, but I think there is several like rules from Boolean rules you need to apply. No need for you to like fully simplify directly.
Got it. Thank you, doctor. Okay.
Okay.
Excuse me, doctor.
Yeah.
We must create a truth table too, right? To insert with the diagram, or we just should
No
just
need.
draw.
No need. You just need to simplify using a De Morgan theorem. But it is not like a final simplification. Only that maybe after you get one input to have only one bar, then it's okay. No need for you to like to have. If you have two input with bar, so you need to still simplify it.
Okay, understood that. Thank you.
Okay. Group number 4, are you finished? Group number 7 also. Let me see. I guess some of you already done the simplification. You just need, for me myself, you just need 3 very simple steps to get the correct answer. So I hope for those who already finished, maybe you can inform your friend how you get the answer in your group, or maybe you need to like patiently wait for others group to finish their work. Okay, we need to give them times to solve. We need to use De Morgan theorem. Yes. Okay, yesterday at night, at 8:30 today, yesterday we did do a discussion for test 1. For those who joined us yesterday, thank you for your participant. Basically, why I asked Doctor, who's the doctor? Dr. Shahida, because we give what separate our tasks, which is she the one who do and handle the test one. So any problem regarding a test one, she need to like explain and then help in the setting and etc. So in test two, next upcoming test two, there will be another lecturer who handle and also final exam. So he like mastering all the question and like setting. I also like having argument with her last time, but yeah, throughout. We need to learn from our lesson. So next time maybe for the test two, she will handle and try to do her best, like solving any error question that occur last our previous test one. So if you have another problem for test one, retest for the retest, you can contact her or maybe direct to me because she still handle the retest. And for those who want to see what we did discuss last night, you can check your e-learning because I already uploaded the recording video. So some of you have done and finished. Okay. Some I can't see you start yet.
Doctor, I do have a question though.
Okay.
Last class, I didn't think you.
What? Hello.
In the last class,
Okay.
we didn't take all of the laws. We only took the first 12. We didn't take the special laws,
What species law?
like the D. Morgan's, the content laws, and the laws.
We didn't learn De Morgan theorem
Yes.
last
No, we
class.
didn't yet.
No, didn't
No.
didn't learn. I know.
Okay. So our last class is until 12 rules.
Yeah.
Okay.
Yes.
Today we continue with De Morgan theorem. Okay. But that's only two simple theorem. Okay, let's see whether because why some of you can like very fast answering it.
Because
I
I
did
think
this
we
in
took
high
it
school.
in.
What?
We took it in high school.
Oh, already. Okay, I'm not going to waste the time because you mentioned you still not yet touch the De Morgan theorem, right? Okay, let me go to the slide first. Later we come back to the Jamboard, okay? Where is it? I'm going to share my screen. Okay, we going to continue our module 4. And if you still remember, we already look into several rules and law. Sorry for the Jamboard, but it is okay for you to try, especially for the two simple De Morgan theorem. Let me recap back what we have learned previously. Before we go to the law, before we go to the rules, and today we're going to look into the theorem. We done to look into the variables, complement, and literals. So I hope that you still remember how to get the literal, variables, and terms. Now you can see you have only three law to remember: commutative law, associative law, and distributive law, which is with the logic, mathematical operation, you have these two very basic law, commutative and associative. And from these two law, you can get the descriptive law. Let's see. You have A plus B, which is equivalent to B plus A. This is our logic. Things that, yeah, you can simply apply it. You have 3 plus 7, you get 7 plus 3. You have 3 times 7, you get the equivalent of 7 plus 3. Multiply with 3. So from here, you have another one, which is you add another variable. You add another variables, but still in multiplication, still in the additions. So this is very simple laws. After that, you have the factorize. So for this distribution law, although in a mathematical, you know it's already, but you need to understand how to apply into your Boolean expression. So in terms of your Boolean, you're going to normally have a question to prove and another one of simplification. And last class, I already also mentioned several times, proof is much more easier. This is my personal mm, opinion, because for proof I know basically I have this question and I need to prove the final answer. If let's say A, then my answer should be A. Whether I go to like Langkawi, I go to the Malacca, I go to Johor, I pusing balik, I go back to Langkawi back, and then I go directly, I get A. It doesn't matter because this is all the step for me to prove, because I know basically the answer. But when you have a question, but it asks you to simplify. Let's say you are from Malaysia. Then people ask you, okay, go and take your PhD. Which way for you can get a very short term of PhD, maybe 3 years. So are you going to go to UK? Are you going to go to London, whatever country? You don't know basically which part and what is your final, whether this is your final answer, to get the final versions of your PhD, let's say. So similar to your question, if you are given the A, B plus AC, what is the simplification version? You have no clue at all for now. That's why I mentioned, simplification is much harder than proof, because you don't know and you don't have any clue what is your final destination. But you will learn later on K-maps. Using K-map, you will get the simplification versions of Boolean. So if let's say you apply your law, you apply your rules, and then you suddenly get, okay, this is my answer. But I don't know whether this is the final simplification or not. So if you want to check, you can use the K-map to check. Oh, if this is correct, also you get A, B plus C, then this is the simplification version. So that will be asking after this in your test and also final exam for proof and simplification. Now, after you have a law, you have 12 rules altogether. This one, all of these rules we already look into, and I ask you to memorize all these 12 rules. But don't just simply memorize. You need to learn how to apply. You need to learn how to apply, and don't just simply do 1, 2, 3 exercise. Then you say, okay, I already master with the Boolean algebra rules. you need to frequently do the exercise. So after you done with your rules, you have another one. Law, rules, and lastly theorem. So in the equation, it's not like last time, you have exercise using only law, exercise using only rules, exercise only the theorem. But throughout, when you learn all together for your test 2, for your final exam, you need to apply all together. You don't have, you will not given the clue. Okay, use rules, use law, use rules number 7, use theorem 1. So it's not going to inform you, but it is directly going to mention. Okay, simplify this Boolean expression and show it in terms of diagram. Simplify and then show the output of your truth table for the simplification. So that is the things that they will going to ask. Now we're going to have another one. As mentioned, is a theorem. Theorem, you only have 2 rules to remember. First, theorem 1 and then theorem 2, which is very simple. Theorem 1, you have exactly the similar answer for NaN if you convert it into a negative XOR. Okay, how to prove? Let's say you were given for your theorem 1, you have X, Y bar. And it mentioned using De Morgan, X, Y bar, 1 only, it's equivalent to X bar plus Y bar. Last time, since your day 1 class, not still your module 1, I already mentioned that if you have X bar, XY bar, it is not X bar, Y bar. If you have X plus Y bar, it is not equivalent to X bar plus Y bar. It is not, okay? So that's why when you learn on De Morgan theorem, you will see that if you have X dot Y, this is multiplication. If you have X multiplied with Y bar, it equivalent to X bar plus, you can see, addition, Y bar. This bar, you're going to, from the long bar, you're going to make the small, which is for one single input. This one, both input are getting the bar, similar bar. But when you convert using your De Morgan theorem, you will get single input. Let me give you another example. X, Y, Z dot multiplication. I convert to my De Morgan theorem. I'm going to convert to be positive. X, Y, Z, all this long bar, I'm going to change it into bar, single bar here. So this is my first, which is Y, Z, X, Y bar equal to X bar plus Y bar, which is from multiplication, I change to additions. And from long bar, I change it into the smallest bar. How to prove? We have X, Y bar, which means X multiply with y, we have a bar, which is not get, or equivalent to NAND get. And our output will be x dot y bar. From this, how the output look like? X, Y, 0, 0, 0, 1, 1, 0, 1, 1. We have the output of, let's say F for the output. We have 0, 0, 0, 1. Why? Because it is AND get. But if let's say we have, this one is F, and for the XY bar, which is NAND get, it will be 1, 1, 1, 0. Okay, done until here. Let's check another one. It mentioned it's similar to this one. What is the meaning by this? Which is negative OR. Negative OR means you have all the bubble here, which is represent as not or negative. How the output will be look like? You're going to have X, Y, 0, 0, 0, 1, 1, 0, 1, 1. So you will have the X bar, Y bar, X bar plus Y bar. This one represent as OR gate. X bar 1, X bar 1, 0, 0. Why this one? It is a toggle from your X value. Now it's Y bar. Y bar will toggle the value of Y, you get 1, 0, 1, 0. Now this is OR operation. OR operation, whatever input have 1, you will get 1 for the output. You're going to get only 0 if your board input is 0 and 0. So this is the only 0, the rest will be 1. Ting ting, you can see this answer is equivalent to your F bar over here, which is X, Y bar. That's why you prove that if you have X bar, Y bar, or which is plus, you will get the equivalent of X, Y dot, and then output is X, Y bar. Okay, that is one thing that you need to memorize. I think you can just memorize it after you like having understanding. Okay, this is correct after you prove already. So you have, again, you have, let's say A, B bar equivalent to your De Morgan theorem. Your multiplication will be your addition. And you have AB. Your long bar, you will be separating into single bar. This is one De Morgan theorem that you need to remember. Second is X plus Y bar. It is equivalent to, first, I tak payah bagi tahu, I'm not going to teach you yet directly, but logically, last time I already mentioned, it is if addition, if multiplication, you change to the additions and your bar will be changed to like this. So apply the similar things. If you have addition, you change it into multiplication, and you have X, Y, all the long bar, you will convert it into single bar. Then you prove the second. How to prove? You check it one by one again. You have x, y, or no, then you will get x, y plus for the output. Let's see the answer. You have x, y, 0, 0, 0, 1, 1, 0, 1, 1. Have x plus 1, 1 0, 1, 1, 1. Yes, just ask me. I can you just check open your microphone, enable your microphone, and then ask me question. Okay, you can see over here you have x, y as the input, and this is your NOR gate. And what is the truth table look like? This is the truth table look like. And you need to prove that when you have negative n means that you have not in front of your AND gate. This one, check back your module 1 or module 3. We already learned on this bubble thing. Okay, from here, let's take a look how the truth table look like. We have x and y again. 0, 0, 0, 1, 1, 0, 1, 1. And we have AND gate. X bar, Y bar, and then AND gates. 1, 1, 0, 0, 1, 0, 1, 1. How I get this? This is a toggle value from each other. From here, I'm going to apply the AND gate. AND gate for this input, 1, 1. The rest will be 0. This output basically similar to the one I got over here. So basically this one and this one is similar. Any question? Apa ni? You cannot enter e-learning. Okay, any question for this part? No question. Ada soalan ke tidak? Hello. Is there any question?
I think
I
it's
think
clear,
it's all
Doctor.
clear.
Okay, thank you. Okay, this is our theorem 1, which one that I already mentioned. So the one that I can basically do for me myself, which is I have the multiplication. If I want to convert it into one single input, get a bar only. So I just convert this to addition. I put the input and all the long bar I will putting at each input. Let's say I have X, Y, Z bar. So I'm going to change this to be plus. So I have X, Y, Z as the input, and all the long bar over here I will put separate. So if let's say I have A, B, C, D, E, long bar here, I'm going to get I put one by one, so then you can easily remember. Dot, 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 dot. I replace all this dot, 1, 2, 3, 4, plus. What input I have? I have input A, I have input B, I have input C, I have input D, and E. All this long bar, I will put separately. So this is the De Morgan theorem 1. For De Morgan theorem 2, we're going to look into De Morgan theorem 2, which is x plus y bar equal to x bar dot y bar. Let's take a look into this. We have A plus B plus C plus D, all long bar. What happened? This addition, I'm going to change it into dot dot dot. What input I got? A, B, C, D. Long bar, I will replace it to be separate bar for each other after I change the operation. So I have over here x plus y. Just change it to be this. This will be changed to the multiplication. Long bar will change it into all the separate bar. Okay, you have this one. And basically this one is similar. That's why, okay, we have this question. Where I put this, put it here, I put it here first. Okay. You have the example of this question. If example applying the Morgan theorem, you have A, B plus C, A plus B, C. So you can see you have the long bar over here. When you see the bar, you automatically will think about De Morgan theorem, especially not a simple single bar, okay? This single bar, no need for you to think about De Morgan theorem, but if you have the combinations of at least 2 input with the bar, then you need to apply De Morgan theorem, at least like A, B bar. A, B bar, you need to convert it into A plus B bar bar using De Morgan theorem. Now you can see over here, this is a simple question that you have. From this question, how you can do, first thing, you see the bar. When you have the bar, what is the operation for the bar? You can see over here, it is a multiplication. For this multiplication, you have A dot B bar. A as AB plus C. B as A plus BC. So what happened? You're going to convert it into plus. Then this will be bar, A will be bar. So you will put A, AB plus C bar, A plus BC bar. You can see? So this is how you're going to apply for the first time, because you have this dot here. And when you see there is another bar, there is another bar. For this one, you can see, oh, this bar is having two variable also, three variables. Then you need to convert it using the De Morgan theorem again. For this case, you have A, B plus C bar. So what is the biggest operation you need to see is this part, which is the addition. You have A, B plus C bar. Oops. This will be your A, this will be your B. So when you convert, you will get A, B bar dot C bar. This convert to be multiplication. This will be bar and bar for the long bar here. And this part also you have another. What you are going to see, you have A plus B bar bar dot C bar. Then you already like having all as one bar for each unit. So let's take a look in a proper figure here. Okay, you have first of all, you have this long bar and you have this multiplication. You change it into addition. This long bar, you will divide and also convert from long bar to be a small bar for each input. Okay, this is one step. After that, you can see this is having another bar. This is having another bar. So from this, you're going to go to, this one is similar things. Okay, you're going to go for, okay, you're going to go to this part first. For this, you will have A, B, this will be converted to dot. This part will be converted to dot. Then you will like bar over here, bar over here. For this will be bar, this will be bar. And for here, addition will be go to the multiplication. This long bar will be separate into each. Okay, how you get this? Basically, it is a long ABC. Don't confuse. You can see? It is A, B bar. You get A, B plus C bar. You have dot C, A, B bar, bar. Bar, bar. Okay? This was is a long bar. And from this and this, you need to convert again using your De Morgan theorem. You need to simplify again. This one, you have A, B bar. What you get, you're going to get addition. This B, this A. This all long, you will having short one. Similar to this part. Don't forget your multiplication, which is applied to all A, B. And similar to this part, you have B, C bar. You're going to get multiplication, you get addition, you have input C, you have input B. This long bar, you will convert it and short it to be B bar, C bar. And don't forget that this multiplication is multiplied to all. Later, you will like multiply again this one, A bar, C bar plus B bar, C bar plus A bar, B bar plus A bar, C bar. Then you can simplify this. You get AC plus B bar, C bar plus A bar, B bar. Then how you can simplify it again? Can you simplify using any Boolean theorem? Then you can try to solve until you get the simplification version. But until this part, you are using the De Morgan theorem. After De Morgan theorem, you can also apply several things inside also for the rules and the law. Okay, we can see there is a very simple question. Prove that A, B bar not equal with A bar, B bar. Using the truth table, this one is very simple. You got A, B, 0, 0, 0, 1, 1, 0, 1, 1 using truth table. We need to get A, B. This one is AND get 0, 0, 0, 1. A, B bar, which is NAND from this part, but this bar is from this only. We get 1, 1, 1, 0. Okay, this is my output for A, B bar. How about my A bar, B bar? We have 0, 0, 0, 1, 1, 0, 1, 1. A, B, I have A bar, B bar, A dot B bar. This one is AND get. I have here convert from my A value 1100, convert from my B value 1010. And from this input, I am using the AND get. So 1, 1, I got 1, 1, 0, I got 0, 0, 1, I got, okay, 0, 1, I got 0, 0, 0, I got 0. So addition, multiplication. So you can see this output for A dot B, A bar, B bar is not similar to my A dot B bar. Not similar or not equal. Then it's proof. Looks in the proper way. So you have this the table and you can like prove it all. The solution. Is it okay? Okay, we have the exercise of 4A.2. Let me show you one by one, then we can go back to our Jamboard. Okay, from this part, I have question number E. I have A plus B plus C, and I have dot D. I have long bar. And this long bar is like equivalent to A, tak nak guna A lah. X dot Y bar. What is my X? What is my Y? What is my Y? So from here, using my De Morgan theorem, what I will do, I'm going to convert from my multiplication, going to be my additions, my long bar, I'm going to apply to my X, each of my variables. So what is my X? My X will be A plus B plus C. And I have converted, I have bar. Plus Y bar. What is my Y? Y is my D bar. So this is my step. And I still see the long bar here. So I need to solve this. From this one, I have addition. I change it into multiplication. I have the input of A, B, and C. Ba, ba, ba. Why? Because this long, I will separate it into several single variable. So my final answer, I will get A bar, B bar, C bar plus with my D bar for this question number A. Is it correct or not? Or maybe is there any other question? If no question, I proceed with question number B. Okay, for my B, this one is also simple. I have A, B, C plus D, E, F. But it is very direct. So I have seen this plus over here, which is similar to my x plus y bar. And my x will be A, B, C. My y will be D, E, F. How to convert? I convert it from adding to multiplication. I have input of x, input of y. I'm going to change the long bar to be a single bar. And my final answer will be A, B, C bar dot D, E, F bar. Uh-oh, this one still not yet finished to solve. I have A, B, C bar. This one, I'm going to change it into plus plus. I have input A, B, C from long bar. I'm going to change it into small bar. And I have another one, D, E, F bar, long bar. So I change it into multiplication. I have F, E, D, long bar. I change it into single bar. This one is dot. So this is my final answer. Okay or not? So next, my question number C. I have A, B bar plus C bar D plus E, F bar. My long bar, I have plus plus. I change it into multiplication. What is my input here? I have input of A, B bar, bar. Okay, I tak nak tunjuk bar ni lagi. Okay, this is my input. What is my input? My input is this one. C bar D. Another input is E, F. And I see this long bar. I'm going to change it and convert it using De Morgan theorem to be single, single, single. Why it not going to get like this? Because my A, B, C is, my A is equivalent to A dot B bar. When I change it to be A bar here, so my A bar equivalent to A dot B bar bar. That's why you put all, not a single bar bar. Okay. So you get A, B bar bar dot C bar D bar dot E, F bar. Still, you need to simplify this using De Morgan theorem. From this part, you have dot, dot, ya Allah, dot, dot, dot. you change it to be addition. We have A as input, B bar as input. So long bar here, we change this to be bar. Have dot here. This bar, we're using the De Morgan theorem. This dot, we change it into addition. We have input of C bar and input D. This long version, we're going to divide it into another small pieces. This dot we bring down, and from here we have another bar long here. Going to change it into plus, and this input E, this input F, and this long we're going to be shortened bar. Then we can like simplify C this one. We have A bar plus B. This one also can simplify C plus D bar. Then we have E plus F. Any question?
No, doctor.
Okay. If there is no question, please continue for those who still not yet finished doing the Jamboard question. I guess group number 1, group number 2, 3, 4, 5, still not yet finished. So 6 and 7 already done. So please try give your friend times to doing the question first, okay? For those who already do, maybe you can go to ladies, take a break first. Okay, I think there is only another one group left. Group number 3. The rest already done. Ke tak ada group 3 ni? Oh, yes. Now, everyone is here. Group number 3. Can you finalize your answer? Okay, done. Okay. So now, Muhammad Adam, where are you from? Group Muhammad Adam, your group 1.
Group 1.
Okay, I'm going to share my screen. Can you explain your answer?
Okay, I'll try to explain.
Okay. Can you just draw in the Jamboard and then explain to us?
For okay, try. Can you go to the 8th slide?
8 slide, okay.
Yeah, I'll try to draw that. Can I explain it?
Yes, sure.
Okay, first of all, I will expand this first. This as the y and this as the z. Yeah, x and y. So look at this.
So this one I simplify it. So we will get this one. And then this one I expand it. It will be like this. And this one will be A plus B plus C plus AB. Okay, so A plus AB will equal to A. So A plus B plus C. Wait. Okay.
You are missing the D bar.
Yeah. Wait. Okay.
Okay, thank you for your explanation. Where I find another. Mana nama? Azhan Hanif, where are you from? Group number? Azhan Hanif, group number 3
Number 3, madam.
Okay. Now you open your cam after I call you. Can you explain the answer?
Yeah. For are we looking at the Okay, can I start?
Yes.
The question given is bar, and A bar B, C bar plus AB plus D. So we need to solve it from the top bar to the bottom. What my friend did and what we discussed is we solve the top bar, which is the ABC plus AB plus D. We make it into ABC times AB times D. Is that clear? Then we change the third line, third bar. Second or third? The second top bar from ABC to A plus B plus C. Lastly, we solve the bar to the simplest form, which is A plus B bar plus C times A plus B times D bar. Is that correct? Or is it A plus B bar?
Can you draw something in your Jamboard so that I understand?
Do you need to explain again?
Yes, because basically for this part, okay, for I'm not really understand. There is a lot of bar, and then what happened here? Because I think your question basically question number 3 and number 1 supposedly similar, but your answer is different. So how about your explanations for this your answer?
Wait. So I explain again like how I understand it.
Yeah.
Okay, for The question given is
Now, can you go to the Jamboard? So okay.
the question given is this one. For the first one, we got like 4 lines, and this one, right? First, we do this first line, which will become ABC times AB times D. Then we go to the second line. Is it wrong?
I think so, because if you want to convert this long bar, isn't it?
Yeah.
You convert to this part.
Yeah.
And then all will be getting as dot.
Yeah.
This one is wrong because you have another bar over here. If you want to solve, you need to look into this to be as one input, and this will be one input. You cannot look deeper inside because there is another bar that represent it also. In this bar, there is another operation, so you cannot change this operation due to this is on by another small bar. You cannot change this inside here because there is another bar that represent it. So if you want to look into like this law, you need to see something like much bigger, which is this is only for this bar, and total another bar here, which is this part to be another one input. That's input A, and this is another input B. Because if you change this one is okay for you to convert to dot, which is multiplication. But if you want to change this to multiplication, you cannot, because there is above here, there is another bar. You can see? Right.
So,
You have another bar over here at the top. This. So you cannot just simply tag this to change to be dot. But this one, you can see this dot represent here, and this bar is represent for the D bar here. And all of these represent to the upper bar. So that's why you can change it to be dot, and this will be your input, this will be your input. So you need to do step by step. Okay. So next time, open your camera. If not, I'm going to call your name again.
Okay.
Okay. Next person. Muhammad Irfan Hakim. Which group you are? Aiman Haikal. Siapa Aiman Haikal? Irfan Hakim.
Group
You dari
group 4.
group 4. Soalan yang sama ke? D, E. Soalan lain. So, can you explain group 4?
Okay.
Okay.
Wait Okay. Okay, first of all, we need to separate this big bar. After we separate it, we will multiply by E. Then, after we separate, there are two same level bar, and we can cancel each other. This bar, two bar.
Okay.
Then we will get A plus B bar, A bar C, multiplied by E bar. Then we can separate these two into A bar multiply B bar. And multiply A bar C, E bar. Then we combine all of it, we will get A bar multiplied by A bar. This is the same as A bar. So the answer is A bar
B bar, C, E bar.
Okay. Thank you for your explanation. So basically, let me summarize. You have only 2 questions from the example, although you have altogether 7 groups. One question is this part, which is you have A bar, B, C bar plus A, B bar again plus D bar. 1, 2, 3. Okay. So from here, you cannot directly like doing all from the small bar. Let's take a look into the first big bar you have. And for this first big bar, this is one input that represent to this bar. And another one is all of this. You cannot see this as another, like this, right? You have AB. AB is not the input for this bar because it is go to second one. This you need to see directly above, but this one there is another bar. Like this C bar, you have this as a bar. You have this as a bar. So you cannot directly jump to this part. So you need to see the big bar first. Alamak. Ada, yay. Sorry lah, I tak familiar dengan Jamboard. We have AB. Okay, so our first big bar is this one. This is our first big bar. And we have this input for the D. And this is another input because this one having this as a bar. And this represent as one input as like say you apply it as X plus with Y. So from here, you change it into dot. Multiplication, this one will be Y bar. This one will be X bar, right? So Y bar will be D bar. Y is your D. X is your all this bar here. When you can see over here, you have A bar, B, C bar plus A, B. This one is bar and you have bar, right? So this is your X. This is your X. And you have bar, that means you have all bar here. This you can cancel it or because you have bar. This one I already informed you, and you need to see also in your rules boolean if you have A bar it equivalent to A, right? So that's why you can cancel. You will get A bar B C bar plus A B bar, and you have D bar over here. Still, you can see this part. There is another long bar that have 1, 2, 3 inputs. So you will convert it into plus. You have A bar as the input, B as the input, C bar as the input, and all this long bar you're going to put at all the input variable. Plus with your A, B, and then you have D bar. So from here, you will get A plus B bar plus C because this one you cancel. And you have AB. You have D bar. Later you can like also make it A D bar plus B bar D bar and etc. So, is there any question related to this? I can see several group get this, and group number 7 is the fastest. Oh, this one is another question. So that is about one question. Another question you can see for this one. Basically, if you go directly, as I mentioned, you have only 3 steps. This one, right? You only have 3 steps. One step you have like A, B, C bar. You have plus A, B dot D. This is one step. Second step, you have A bar, B, C bar plus A, B dot D bar. And finally, you will get A, B. Similar also to another question, which is this question also you have only 3 steps. You can see 1, 2, 3 steps. This one is you already simplify it. Kenapa tak boleh? Okay. Now for this question, you can see also similar things. When you have this part, you have this as this input for this bar, and these all as one input for this bottom up bar, for this upper bar. So this is one input and this is one input, and the operation is plus. So you change it into multiplication. So you have E as the input, and of course you're going to put the bar. So what is the input for this part? A plus B bar, A bar C, and this long bar as the input only. So because you're going to put the bar on the top. So you remove this one because it is bar. So you have a E bar. Now from here you have another one. So you can see you have A dot B bar because you convert it. You have A C and you have E. After this you can like make it bigger like this one. So it is very simple if you understood and understand the theorem. As mentioned, you can memorize x plus y bar equal to x bar dot y bar. You can memorize it easily, but on how to apply into the equation is the problem. So if you understand how to apply, then easier for you. Is it okay? So for these two questions, is there any question that you want to rise up? What is the issues? Any question? So if there is no question, I think we can end up our session for today. Tomorrow, please remind me, we're going to go directly to our combination logic representation, especially for truth table and logic circuit. Because I hope that by tomorrow we will finish our module 4A. Okay. So thank you for your participant. I'm going to share last time for the QR code. For the rest, you can leave. Thank you and stay safe. Bye-bye.
Thank you, Doctor.
Okay.
Thank you, doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, doctor.
Thank you,
Okay.
doctor.
Thank you, Doctor.
Okay.
Thank you, doctor.
Okay.